So when we're looking at trigonometry, there's a few key things that we need to be able to do, and one is to be able to identify the opposite, adjacent, and hypotenuse sides of a right angle triangle. To highlight that real quick, I want to remind you guys that trigonometry only works with right angle triangles. So make sure you don't use it on a non-right angle triangle. So, opposite sides. Opposite sides are always opposite of the angle you're interested in. And I'm saying interested in because sometimes it's the angle you want, and sometimes it's an angle that you've been given. So if we take a look at this example here, we see the right angle here in the corner, shown by the little box. That's not the angle I'm talking about. The one I'm talking about here is the one highlighted by the little arc going through it, and that has been labeled A. So this is the angle of interest for us. Now the opposite side is going to be the one on the other end of it. This is going to be the opposite side. And one way to think about that is if you draw little pointy teeth on the angle, that's the side that it would eat inside of its jaws. Okay, if it was a big crocodile, it's going to eat the opposite side. So it is directly opposite of the angle. It's not touching it, it's nowhere near it. The angle, in fact, can kind of wave across the triangle to the other side and say, hey, opposite, way over there. So that's our opposite angle, our opposite side. The next one to look at would be the adjacent, and adjacent literally means to touch. And so the adjacent side is the one touching the angle of interest. And in this case, it happens to be the short side here, the adjacent. And another way people sometimes think of this is that it's the side that's between the right angle and the angle of interest. So it's actually connecting the right angle to the angle of interest. It's adjacent to the two angles. And the last side to identify here would be the hypotenuse. And it's always going to be the longest side of the triangle. And it's always across from the right angle. So if we go straight across from the right angle, we get the hypotenuse. So the hypotenuse is opposite the right angle, if you will. And the opposite side of our triangle is going to be opposite of the angle of interest. And the adjacent, again, is tucked between the two, the right angle and the angle that you're looking for or have been given. So give a think, trying to see if you can solve for which angles or which sides are which in these three diagrams. Again, thinking about what is opposite, where's the angle that you're looking for or that you're given, and where the right angle is. So in this problem, I'm going to identify the opposite angle, again being straight across from the angle of interest. That's going to be my opposite. My adjacent is actually touching the angle of interest and is in between the angle of interest and the right angle. And my hypotenuse is going to be opposite of the right angle, and it's the longest side. And in the last example here, again, think about the opposite side being the one way across the other side of the triangle, all the way across, and you could think about having little jaws. It's going to eat that side if it could. And this is going to be the opposite, way on the other side from the angle that you're interested in. The adjacent will again be between the angle of interest and the right angle. So again, it's kind of messy, eh? This is going to be the adjacent side. It's connecting the two angles, the right angle and the angle of interest, and it's touching the angle of interest. And finally, our hypotenuse will be opposite of the right angle. So when you're solving these problems, you want to make sure that you can label correctly the sides of the triangle. But as a hint for yourself, it's generally a good idea to only label the two that are actually of interest to you. But I'll show that in the next video, talking about how to actually use this information. And again, right angle triangles only.